Topic is refrigeration engineering. Basic concept of refrigeration. Okay. Basic refrigeration cycle we have from expansion valve going to evaporator, then compressor, then condenser, then back to expansion valve, another cycle again. That's the basic refrigeration cycle. Next, so what we have is vapor compression cycle. Vapor compression refrigeration system, again, from expansion valve, which is on this expansion valve, from condenser, refrigerant changes from gas to liquid, and condenser discharge heat into surroundings. Then going to uh, expansion valve separates high pressure from low pressure side. Okay, our low pressure side is uh, the the evaporator, okay? And the high pressure side is the condenser. On expansion valve, there is a constant enthalpy. The next is evaporator. On evaporator, refrigerant changes from liquid to gas because evaporator removes heat from surroundings. Dito na yung lumalamig. This is uh, dito na yung lumalamig na side. Next, we have compressor. Refrigerant gas is compressed from low to high pressure here in compressor. Refrigerant in gas state, refrigerant in liquid state, papuntang condenser. What is refrigeration, by the way? Refrigeration is cooling by the removal of heat, the movement of heat from a place where it is not wanted to a place where it is unobjectionable. That is refrigeration. And some concepts of refrigeration is heat. Heat is a form of energy. And how about cold? Cold is absence of heat. Then how does heat flow? High heat to low heat. That is how heat flow, from high to low heat in refrigeration. Does cold flow? No. How is heat measured? In BTU or British Thermal British Thermal Unit or BTU. Heat is form of energy and is measured in BTU. A BTU is the quantity of heat required to raise the temperature of 1 pound of water and 1 degree Fahrenheit. Heat flows from high energy levels to a lower energy level. Heat will not flow without a temperature difference, of course. Uh, the greater the temperature difference, the faster the heat will flow. Heat flows in three ways. We have radiation, convection, and conduction. We have this is what we call heat transfer concept. We have radiation, convection, and conduction. Conduction, the transfer of heat from molecule to molecule through a substance by chain collision. Example, heating one end of a copper tube will cause the other end to get hot. Okay? That's what we call conduction. Next is convection. Heat transfer by the movement of molecules from one place to another. Example is convection oven, forced air furnace. Another example. Next is radiation. The transfer of heat by passing from a source to an absorbent surface without heating the space in between. Example, sunlight goes through a window without heating the glass but heats the surface in the room it is shining on. Temperature, another concept. Temperature indicates the average velocity of molecules of a substance. Also, as the heat energy in a substance increases, its molecules vibrate more intensely. A thermometer measures the intensity of this vibration. Okay, these molecules vibration. Thermometer do not measure heat; they measure the effect of heat. Specific heat. Okay, specific heat, the amount of heat measured in British thermal units required to raise 1 pound of a substance 1 degree Fahrenheit. We have substance for water. The specific heat is 1. Temperature rise is 1 from 1 BTU addition. We have ice, steam, aluminum, brass. Physical state of a substance. We have gas, liquid, solid. Right? And others, but these are the basic. Okay? These are the fundamental state of a substance: gas, liquid, and solid. When adding heat energy in any of the three states, it increases the temperature. Changing the state of a substance will require a larger quantity of heat energy. Heat energy, what's the? There are two types of heat energy. We have sensible heat and latent. That there is a causes in temperature with no change in state. Here causes in change in state while there is no change in temperature. Okay, it cannot be measured with thermometer. Okay? That is latent. And refrigeration. Refrigeration also is mechanical refrigeration works by changing the state of the refrigerant. The majority of heat is removed from the temperature-controlled space as the refrigerant absorbs heat when it changes state from a liquid to a gas in the evaporator. Majority of absorbed heat is removed from the refrigeration system in the condenser as the refrigerant changes state from gas back to liquid.